Good morning, and thank you very much for having me as well. I have warm feelings for Estonia since we had a really good basketball player over here in Groningen from Estonia in the past. So um, next to the fact that we really like to work with you, I also have nice feelings and memories from that. I'd love to tell you something about our hydrogen trains project. And if you paid attention to Patrick's mobility sheet, then you didn't saw the hydrogen trains yet. That's because we still have diesel trains over here in the Netherlands on our tracks. And my clicker doesn't seem to work as well, so maybe you can go to the next slide for me. Thank you very much. So what you see over here, I don't need to point out where the Northern Netherlands is anymore because Patrick already did so. But what is really interesting, I think, on this slide is this is an overview of our current train network. And all the blue lines are the lines that are already electrified with the catenary system. And all the red lines you see are the lines that are still diesel engine tracks. And what is interesting to see is that the Northern Netherlands, all the lines over there, except for the one going to the south, but all the lines that are regional tendered and driven by Arriva, Deutsche Bahn company, are still diesel tracks. So some people in our region say that that is a disadvantage. We believe, as provinces, as a region, we believe that it could also be an advantage because, well, you can convert the whole part of the Northern Netherlands in one time, and you still have a lot of options because you don't have any catenary systems yet. You can also choose for a different system to go to zero emission solutions, of course, because that is the aim. And if you go to the next slide, thank you very much. Then you see what we did. 2 or 3 years ago, we started an investigation because our aim is in 2035 ultimately to go to zero emission trains on our tracks. And then you have 3 options basically right now. And the first option is, of course, the ordinary catenary system with overhead wiring. We investigated that. And then you have some benefits, of course, because you can connect to the rest of the Netherlands, but you have a lot of you have a lot of negative aspects for it as well. And the main negative aspect is that it's really expensive to do so. And there's of course a disadvantage for a failure system in the catenary and stuff like that, where you get delays with the trains. And then we also looked into a partial catenary system with battery trains. And what we saw over there was that the battery trains right now still need a lot of catenary systems. So basically we would still need to invest a lot in the overhead wires on our total network. On top of the things I just said about the catenary system, this would also take a lot of time to build. And of course, it is a bad thing to have a system which is, basically not capable of being built flexible, because that's basically what we are looking for. And if you build a catenary system, you have to at least build it over one line so the trains can run. It's not possible to build just a small part of a line, so then you have to invest a lot in one time. And the third option we looked into are actually the hydrogen trains. It says hydrogen battery trains because hydrogen trains still also have a battery system in it. And this turned out to be actually the most interesting one. If you can go to the next slide for me. Because there were a lot of advantages for the hydrogen trains. If you compare it to a catenary system, it's up to 50% lower investment. A catenary system, a full catenary system in the Northern Netherlands on all the red lines you just saw is about 700 million euros in only the investment. And if we look at the total system for hydrogen, so also the refueling, which in our case should be with green hydrogen, of course, otherwise the total system would not be zero emission, that would cost up about 300 million. So it's still a lot of money, but it's 50% lower than the catenary system. And another big advantage for hydrogen trains is that it can be flexible to introduce the hydrogen trains. We have up about 70 trains in the northern Netherlands, and what we can do with hydrogen trains is replace the trains, not as a total all at once, but replace maybe 2 or 3 at first, or when there's a new line coming, when we need new trains, then we only change those trains into hydrogen trains. So it's way more flexible than a catenary system, because then, what I just said, you need to at least build one line and maybe even the whole system all at once. Compared to catenary, so like I just said, you don't have the catenary failures during the daily procedure, and you also don't have blocking views from the overhead wiring system for the people who live near the train system. And what you don't have, of course, also is the maintenance cost for a catenary system. Another interesting advantage for hydrogen trains that came up was that there's less noise. It's at least 3 and even up to 6 dB compared to diesel trains, less noise, which, if you know the sound measure system, 3 dB is around about 50% lower intensity of noise. And of course, it's easy to cross borders, because right now we have a line going into Germany, and what we need to do, because there's another catenary system over there, is change locks all the time when we cross the border. And with hydrogen trains, since there's no overhead wiring, you don't need to change the lock anymore as well. So that's great. That's a great one as well. And like we just heard, it fits perfectly within our total hydrogen strategy, which was explained by Patrick already. The next slide, please. So I'm not going to explain to you this slide anymore, because Patrick already did perfectly. This is our hydrogen economy system. And if you can go to the next one, because it's good to remember this one. This is an overview of the hydrogen mobility that is already in place and the potential hydrogen mobility. So what you see over here is basically all the things Patrick already mentioned, with the refueling stations in Emmen, the Eemshaven Harbor, Delfzijl, and the city of Groningen, for instance, but also one in Pesse in Drenthe, in the province of Drenthe, and the mobility solutions that are already in place, like the garbage trucks, the 32 buses, a lot of hydrogen cars, and the potential, like I just explained, for 72 hydrogen trains. The next slide, please. Of course, there are also some disadvantages for hydrogen. It is still a big investment, so you need a lot of money to invest in it. But like I said, it's if you want to go to zero emissions at this moment, it is the cheapest solution. Then the technique is still in development. So hydrogen trains are currently only used in Germany. So there's some development. So there are chances for when you start that there are some malfunctions or things like that. Another one that is that the current available hydrogen trains have a maximum speed of 140 kilometers an hour. For now, I say, because, the development is going on, but you should take that into account if you want to run hydrogen trains at this moment on your tracks. The tracks need to be suitable for that. And of course, the tanking procedure needs to be fit in within the total process. The next slide, please. So what we did, because we saw some of these potential disadvantages, is say, okay, let's do a pilot first to test if it's actually suitable for our tracks. So we tested for 2 weeks the performance of the hydrogen train, the refueling process, and we also organized a public and press event. to have the public to introduce the hydrogen train to the public as well. And what we gained from this pilot is also a dispensation, because there had never run a hydrogen train before on our tracks, so the National Safety Authority need to give us a dispensation, and we learned a lot from that as well for the actual introduction later on of hydrogen trains in our system. The next slide, please. So these are just some slides about the results of the pilot. What you see over here is we tested an Intercity train and a regional stopping train. So the Intercity train runs between the capital city of Groningen, which is Groningen, and the capital city of the province of Friesland, which is Leeuwarden. It's a track of about 55 kilometers, and we tested the timetable of the normal diesel train. And these are the results of the hydrogen train. And what you see is that at the end station, it except for one time on the 8th of March, it runs perfectly on time with the same timetable. And the one on the 8th of March wasn't because of the hydrogen train. It was because the hydrogen train needed to stop for a red sign because another train, a diesel train, was delayed. So these were really good results. The next slide, please. You see the same with the regional stopping train. Like I said, this is this is a train with a timetable that stops at every station in between. And what you see over there is that it is fully capable of meeting the timetable of the diesel train. The next, please. We also measured the noise, because in theory they said that it was an Alstom train, and the people from Alstom said it's up to 3 dB less noise, like I just explained. So what you see over here is a comparison between the diesel train and the hydrogen train from Alstom, and we actually saw that the 3 dB difference is actually in practice there as well. So that's really good news for the people living near the track as well. The next, please. This is a timetable of the refueling. So we refueled the train 6 times in 2 weeks. And what we saw was that even with the temporary refueling station, which we placed over there with the tube trailer, the refueling process went way faster than we expected. If you look at the starting time and the time that it was ready, you see that it's up about 15 minutes to refuel the train. So that could fit perfectly within, of course, an overnight refueling, or even maybe sometimes in between a day routine of the public transport company. So that was really well, better than we expected on forehand. And in the next slide, you can see that well, the pressure we used, and that it stayed all of the time, it stayed the same, and we didn't have any malfunctions in there as well. And the next. This is an overview of basically the public and press event that we organized. There was a lot of public interested in the train. We did it on a Saturday, so people were actually free to come, and they could walk through the train, get explanations from all the parties involved. So our public transport company Arriva, the refueling company Engie, who delivered the green hydrogen, and the refueling station. Of course, there were people from Alstom there to explain some things about the train. And we were there as a province of Groningen with our regional minister, and also the national minister is in this picture as well, because she was really interested in our pilot as well. So, well, concluding that the pilot went basically really well, and we made a report about that. I can send that to the organization so you can look it in, because we made it in English as well. The next, please. What are the next steps? Like I said, the pilot was very successful. What we like to do now is scale up towards a first run with 4 new trains. We need 4 new trains actually in 2025, and we want them to be hydrogen trains, so then we can fully test for 1 or 2 years in the real operation how the hydrogen trains behave during a longer period than the 2 weeks we did so far, which is a perfect step in between. And every train after that we need that is new will be a hydrogen train then as well, if of course the scale up goes well. But we have no reason to doubt that at this point. And then the train concession, as you might know, are always for 15 years in the Netherlands. So we have a concession right now that starts in the end of this year and runs up until 2035. So the trains for that are already built and delivered. But our aim is at the end of that concession in 2035 to have all these trains replaced by zero emission trains. And for that we need to start ordering the trains so they can be built around 2030. So that gives us 2 to 3 years to test the 4 trains and maybe even other trains that need to be there when we have new trains, when there are new trains necessary, before we need to start making the tender in 2028, so the trains can be built in 2030. And an interesting fact, also I think for Estonia, if you're interested in hydrogen trains, for us it's really interesting if other regions in Europe, or maybe even outside of Europe, but at least within Europe, or countries are interested in changing their diesel tracks into hydrogen trains, because then of course we get a bigger market potential and we can really boost the development of hydrogen trains. And the next, so this is a picture of the pilot. What I didn't said, but we did a pilot during the night times, so outside of the regular duration, but for the timetable that didn't change anything. So if there are any questions, I will be happy to answer them.
Thank you very much, Daniël. And indeed, we have quite a few questions. But first, again, I would like to congratulate you on all the work you're doing there. It's very fascinating and also very educational for us all. So to really understand like what is the best way forward. And really, I was also last year asked that question, and as not really a specific expert on this topic, what is the break-even point between catenary trains and hydrogen trains? So if you were to only have these two technologies, why would you choose one of those? Why would you choose the other?
Well, there are several reasons why you can choose one or another. I think if you remember the map, then there's a region in the south of the Netherlands with only one train line, one railroad line, which is still not with a catenary system, but the rest of that region is fully built with catenary system. So then it makes more sense to replace that one line maybe with a catenary system, and then of course one line is not that expensive to invest in compared to the 7 lines that we have in the north of the Netherlands. So I think one reason is the way your region is already organized right now, and of course the money it will take. So yeah, if you look at break-even points, that's a really good one to look into. How is your region organized, and also how is your region going forward to the future? Because for us, it's really interesting to go to hydrogen as well, because we have the whole hydrogen system behind it. So we can get the green hydrogen as well in our region, and actually give the hydrogen economy a boost by investing in hydrogen trains. So that is of course a big point for us as well. And I think another important one is the one I explained earlier about the flexibility. If you want to have flexibility, then it's way better to invest in a solution, a zero emission solution in the material, so in the trains, than to invest in a solution in the train lines, because then you always have to do at least a total line, or maybe even your total network if your trains run on different lines, because otherwise you need two systems in one. So that's a really important one as well.
Yeah. So the very interesting thing is that in Estonia, for the longest part, diesel trains have actually been much greener than the catenary trains that we have, because, of course, our production of electricity has been extremely dirty. So in that sense, diesel trains were actually much more preferable in the environmental impact. So it's very difficult to consider that. But of course, right now, what the consideration is, and some decisions have already been made, is that we have one central hub, our capital in Tallinn, and then we have 3 longer routes. And so the question is whether we should really install all the catenary lines, or we should have one central hub in Tallinn. And in order to encompass that, it's very important, like, what is the range of these hydrogen trains?
Well, just to go into your first point for a little while, I think if you don't use green hydrogen, you shouldn't invest in hydrogen trains, because then it's the same as the catenary system you just explained. And, well, it's basically still fossil fueled energy. So for us, it's a demand that it should be totally green energy. And in the 300 million I explained earlier, there's an investment in wind and solar energy as well to make that green hydrogen. And then to go into your question, can you repeat it for me?
What is the range of a typical hydrogen train?
Yeah, the range. Well, the trains we tested, they go up to between 800 and 1,000 kilometers a day before they need to be refueled again.
Okay, so basically, given that the distances are quite short in Estonia, usually maximum 200 kilometers, one train can refuel once per day and ride back and forth twice, and then refuel again.
Yeah, but it depends on your tracks. If there are like really steep parts, or you need to run all of the time with 140 kilometers, then of course you need more hydrogen than in our case. We have, like you probably know, we have no mountains in the Netherlands or steep railroad tracks or something like that. Well, that really makes a difference. What are the characteristics of your area? For us, it's 800 to 1,000, but it could vary a little bit depending on your region.
Yes, we have a few mountains, but they're only 300 meters tall, so not too much. So I don't think that would be really an issue. We have similar landscape to what yours. So do you think it then would be possible to just build one big refueling infrastructure at the central point and then run all the lines from this central point and just cut costs dramatically in that way?
I think it can be possible we are actually aiming for one big refueling station where the trains are parked overnight, but we do have a backup solution, and I think that is really important when you choose for hydrogen. Make sure you don't depend on one refueling station, because what if something happens on a refueling station or near the refueling station and you need to close it down or something like that, and the trains cannot be refueled, then you cannot run the total procedures during the daytime for your timetable. So it's really good to invest in a backup system as well.
Okay, so just keep the old trains as well.
No, what I mean with backup system is a second refueling option.
Okay.
So either with tube trailers or maybe a refueling station somewhere else where you can drive the trains to.
Okay, so a larger storage of hydrogen just in case. Okay.
Yeah.
So a question from the audience is, why is the top speed of a hydrogen train, well, let's say only 140 kilometers an hour? Well, in Estonia, they actually run at maximum 140 kilometers an hour. So, yeah, why is that?
Yeah, it has something to do with the electric engine that is inside the hydrogen trains and the battery. The battery package that is, like I explained, there's still a battery package within a hydrogen train, and that runs out of energy really fast when you go higher than 140 kilometers. And you need both. You need hydrogen and the battery package system to, well, for instance, stop and run off again from a station. And after you accelerate it, then the hydrogen kicks in, and the train only runs on hydrogen. But especially on those stops, you need a battery package system. And during the daytime, of course, when you run at a maximum speed all of the time, then the hydrogen runs out. You run out of energy out of hydrogen really fast. So that's why they kind of calibrated the engine for a maximum of 140. Otherwise, it will be really inefficient to drive the trains. But there are developments looking into trains that can run even 200.
Okay, I saw that refueling these trains were at 200 bar and 170 bar, which is considerably lower than what is used for other transportation. So is there any specific reasoning for that?
Well, there is, but it was only because it was a temporary refueling station, and we were not allowed to use 350 bar for this, because normally it's 350 or 700. And we, out of safety reasons, because it was a temporary system, we were not allowed to use that.
Okay, so
so if you build a permanent refueling station, it would be higher.
Okay, so again, thank you very much. Extremely fascinating, and I really hope that Estonians can work together with you and your projects in order to develop something here as well. So thank you.